What's going on YouTube? This is Ipsec. We're doing code from HackTheBox, which is a pretty easy machine, but there is definitely something that could trip people up during the root step if they try to run the exploit out of a temp directory like dev shm or /temp, because the sticky bit is set there, which is preventing root from modifying files. I'll do a thorough explanation at the very end of the video, but before we get into the privask, we first have to get a shell on the box. And that is through a website that allows us to just run Python code, but there is a filter in place that's preventing a lot of bad words from being said. This step's pretty easy if you just pull up a sandbox evasion cheat sheet and try proof of concepts until they work, but I'll do my best to do it manually and explain exactly how it works under the hood. So if it sounds complicated, don't be intimidated. You don't have to understand how it works, but I just like to explain things in depth. After that, we get code execution, we can dump the database, and then exploit a backup script, which is where that temp directory thing I mentioned earlier comes into play. So with that being said, let's just jump in. As always, we can begin with an nmap. So -sc for default scripts, as v, enumerate versions, -vv for double verbose. This gives us things like the TTL, OA, output all formats, put in the nmap directory and call it code, and then the IP address of 10.10.11.62. This can take some time to run, so I've already ran it. Looking at the results, we have just two ports open, the first one being SSH on port 22, and the banner tells us it's an Ubuntu server. We also have HTTP on port 5000, and the banner tells us it's running gunicorn, which is a Python library, and the title of the HTTP page is Python Code Editor, so everything lines up. This is definitely going to be a Python website. It's also exposing the gunicorn version of 20.04, and we could look for vulnerabilities there, but Python Code Editor sounds like a really juicy website, so let's just go take a look there. So I'm going to go to 10.10.11.62, port 5000, and we get, looks like a web IDE type thing. If I click run, it prints hello world, so it is running Python code. The first thing I'm going to do is try to run a system command, so I'll do import os, then os.system, and then let's just run ID. And if we try this, we get use of restricted keywords is not allowed. So the next thing I normally try to do is include files, right? So we can do with open, let's do etc passwd as read, and this would be called f, and we can do f.readlines and see if I can print this out. And we still get use of keywords is not allowed. So now I want to see exactly how this filter is in place, right? Is it just looking at the input we send to the web server, or is it actually hooking in the Python code and seeing what is being executed? So I'm just going to comment this out, and then we'll just do a print. Let's do please subscribe, and then we'll send it. And we still get the same thing. So I'm just going to confirm the thing is still working. So I'll just erase that, and we get it. So it's just looking at the text we send it, right? We could find out what bad words there are. So if we just do print, let's try import, click run, that's not allowed. Test, that looks like it is. With is allowed. Let's try open, and that is not allowed. We could also play with case sensitivity, and looks like that is still being restricted. So we kind of have an idea what the filter is in place. And this is going to be where I make it a little bit more complicated than it is, because in reality, you could probably just go and Google Python sandbox evasion cheat sheet, and then copy and paste a bunch of things until something works, right? Let's see. I'm not finding something I'm familiar with. Let's just look at some of these. That's not it. Let's see. Sandbox evasion cheat sheet. If we do it on DuckDuckGo, do we get anything different? I think this page I recognize. This is a defense thing of people evading. There's something here of just giving a lot of things to run. We know this won't work probably because we tried it. There's popen as well. We could check if os is a bad word. So we could do print os, run. That looks like a bad word as well. So when you combine the knowledge of what bad words there are, you kind of guess which one to use. And some of these get relatively complicated. And I'm going to step through it, so hopefully you can understand by the end of it. Not sure exactly where some of them are. This is complicated, right? What the heck is going on here? It's got a list comprehension, which is not a beginner thing, doing something with this class-based what is going on there? So this is essentially what we're going to do, but just step through it, right? So it all starts with that class base subclasses. So let's run this real quick. So I'm going to do a, let's do print. Let's make sure my syntax is right. We'll do class base, then sub. I got to do the dunders, sub classes. And if we run this, we get invalid syntax because we screwed something up. I'm using Python 2 syntax. That hasn't happened in a while. There we go. So this is going to list every class that is currently loaded. And if we guess where this class is, we can actually reference it and use it, right? So the key step here now is finding where a dangerous one exists. So I'm going to change this print statement up and do like for C in. I'm using C because C can stand for classes, right? And then we can do print C dot, and then this should have like a name attribute. And if we run it, we get a list of everything, right? And some have case like a capital letter. So what I also want to do is change this to lower just to make it easier for me to find. And there we go. Everything has been changed to lowercase. So now what we want to do is find out where these are all loaded, because this is just a giant, I want to say list, but it's like an array, right? So I'm going to set I is equal to 0, and then we'll do I plus equals 1, and we'll do print the string of I, then plus a space and this, right? So what this is going to enable me to do is say, hey, type is loaded at 1, weak ref is loaded at, or type is loaded at 0, weak ref is loaded at 1, weak callable proxy is 2. So what I want to do is find a library that's loaded that I can get command execution from. So we're just going to change this to be, let's see, we'll put an if statement here. So we can do if c name dot lower is equal to, let's do OS, right? We're going to see if OS or system. We'll look for the system command. When we print, we run, we have the keywords not allowed. But we can now break this string up. So we can do like sy, then st, then em. So when Python combines this all, it becomes system, and we don't have anything. Let's try like popen. That's another common way to get code execution, right? So if we change this, we do run, and we see popen is loaded at 317. So what we can do with this information is, let's comment everything out real quick, because I can leave this here so you can read it if you want. But I can now run popen commands. So I'm going to copy this, and then we're going to say at 317, and now I'm just in popen, right? So popen, you give it a list. The first thing is going to be the binary, and then you can do comma and parameters, right? That's how you run popen. So if I run this, we click run, I'm not getting any output. I'm just going to do a ping, then dash, is it dash C or dash N? I always get this mixed up. I think it's dash C on Linux. I just want to make sure I only ping once, because if I let this open and we ran it, it's just going to do like an indefinite ping, and I never want that, right? So I'm doing dash C, we'll do 1, and we can say 10, 10, 14, 8. So we're just going to test if we have code execution here. So I'm going to do sudo tcp dump -i ton 0 icmp. And then when I click run here, we can see the server does indeed ping us, right? So we could easily now go for an RCE. So I'm going to listen on 9001, and then I'm going to create a like web cradle, like not web cradle, a base64 thing of just to get code execution, right? So the standard one-liner shell, 14.8, 9001, 0, and 1 like that. We'll base64 it. And then I always like making sure there's no like special characters in base64, because why not? Every now and then those special characters will screw you over. I just put 2 spaces here. I kind of eyeballed where that plus was, and that got rid of the plus. It also got rid of the equals here. So now I just have an alphanumeric payload, which is very easy to use. So we can say, actually, before we do this, let's make it easier for us to run commands, right? So I'm going to change the ping to be a bash, then we'll do -c, and then we'll put our script here. So we can do echo, paste this all in, base64-d, and run bash. When we click run, we get a reverse shell. So let's get a proper PTY. So we'll do python-c, import PTY, pty.spawn, bin bash. I forgot the single quote. Python3-c. Let's put this in. That error message was because I did Python, not Python 3. And my whole terminal died. That was odd. I'm going to exit this real quick. There we go. Let's listen again. NCLVNP 9001. Let's run this. Send this. Then STTY raw minus echo foreground. Enter, enter. And then export term is equal to X term. And that'll let us clear the screen. I'm not sure if after like a minute this shell would die or not. So I kind of want to know if it does. So let's go and overcomplicate this payload real quick. So we have a one-liner here, but we already knew what this 317 was. If we look at kind of how they're doing it, they're like going overcomplicated with a list comprehension. So let's use that. So if we didn't know popen was at 317, how can we do that, right? Well, for starters, if we had this, we don't need that. We could just say if cname lower, then we can say, actually we do need the I. No, we don't. Then we could just do like C and commands, right? So we want to convert this essentially into one line. So to do that, I'm going to say x for x in, and then I'm going to copy this. And then what we're going to say is if x name lower is equal to, then p plus op plus en. Okay. I'm screwing something up because I've got a parenthesis there. So what this is going to do is essentially, let's put it down here. This terminal is still working. So I think after stabilizing my shell, it became more stable. So what this command is going to do is return a list of all the subclasses that are loaded that have the name popen. So I'm just going to now do a 0 because I just want to get the very first item. And then we can do a command. So I'm just going to copy and paste that reverse shell command. Right? There we go. Paste that there. And let's delete everything and hope we did it correctly. So let's do nc lvnp 9001. Run this. Not erroring. And we get a shell. So hopefully now, like all those complex payloads that you just copy and paste and blindly run make somewhat sense, right? This is just list comprehension to get a if-then comparison on one line. And yeah, so I don't know what else to say there. So let's just go back to the box where we have the shell. So whenever I land on a web server, I like to extract any credentials. And I know we kind of skipped over like the ability to save, register, log in because running commands just looks so interesting, but it's got a register and log in, so it's got to have users, right? So let's look at app.py and then let's see where the database is. If we go all the way up, we see it's looking at databases.db. So I'm just going to do a find dot-type f. If we do this, is there too many files? There's not. Awesome. We have databases.db right here in instance. So if we do cd instance, we have database.db. So I'm just going to do SQLite database.db, we do a .dump, and we see there's two MD5 hashes for development and Martin. So I'm just going to, and I'm saying MD5 because I can just eyeball this. This is going to be 32 characters, right? Echo-n, WC-c, yep, 32. Whenever you see like a 32 character string, probably MD5 some because it's that common. But we can do crackstation.net. And then I'm just going to input these MD5s. We could send it over to like Hashcat and try to crack it, but whenever I get MD5s that are like unsalted, my first instinct is always just to use Hashcat, right? And the first hash is development. The second half is Nafil Sword Master. And that's going to be Martin. And if I cat etc pass WD, and I'm going to grep for everything that ends in SH because those are going to be the shells, we see there's a user called Martin. So I'm going to just try SSHing as Martin at 10.10.11.62, I think the IP was. Yes, it is. Put the password in, and we get logged in. We do a ls. We can see user.txt isn't there. I bet it's in app production. Yes, it was in app production. But looking at Martin, there is a backups directory. If I look at backups, we can see Martin owns this, and there's also a task.json. So if I cat task.json, the destination is home Martin backups, and it's backing up the production app. We could go look at this backup, but I'm also just going to run a sudo, and we see I can run this script backy.sh, right? If I didn't have anything in sudo, I'd probably look at like set UID binaries. If nothing there, then I'd probably go examine this backup because there may be a different password in there, and then try to crack that password. Maybe that's going to be root or something like that. But we have this backup script. So let's go ahead and take a look at it. So I'm going to open up in Vim, and we see the usage. It wants us to give it task.json. So the very first argument is a JSON file. If it's not, then it's going to say not found. Allowed paths is going to be /var/home. And then it's running this JQ. And I don't know exactly what this is doing. I'm going to copy this to my clipboard. But we're going to do a JQ on this parameter, directories to archive. Then we're going to do a map gsub. I'm guessing this is going to be .. and these escapes are serving at, these backslashes are serving as escapes. So we're just replacing .. probably with nothing is my guess. And then we're going to echo the updated JSON to the JSON file. And looks like we're going to then start backing it up, right? So if allowed path for directory, and then runs it. So let's now figure out exactly what that JQ command is doing. So I'm going to copy the task.json over to dev shm. And then we can go in there, and then I'm going to paste this. I'm going to do task.json. There we go. And we see pretty much exactly what that file is. So I'm going to go v task.json. And then the attribute it is looking at is directories to archive. And then the allowed path is in home or opt, I think it was. So I'm just going to do home. I think there was a comma there. Maybe it was this. No. Forget exactly what it was. Just a quote. Okay. So do the quote. I'm going to put .. And let's see what happens to this. So we're going to rerun that JQ command, and it erased that .. If we do multiple .. let's see what happens. So we'll do 2, run the thing again, and it erased it again. So now I'm curious if that map gsub command we're running is going to be recursive. And what that means is after it does the replace, does it check it again? Maybe it's iterative, not recursive. I may be messing up terminology. So what I'm going to do is a dot, then .. You could also do like 4 dots and then 2 slashes. There's a lot of ways you can go about this. But what this is going to do is when it removes the .. it's left with one here. So by removing it, it creates the .. And if it doesn't check the string again, then we now have a bypass to that path sanitization, right? So running it again, there we go. We see now we're at home ... So we have successfully bypassed that detection. So what I want to do is back up root, and the destination, I'm just going to put this to dev.shm, right? Dev.shm, and then might as well set verbose log to true, because whenever I'm like playing with things, I want verbosity. So if it fails, I know why, right? And it's excluding anything that begins with a period. I'm going to get rid of the exclusions because I want to back up everything. So let's see what happens here. So I'm going to do sudo-l so we can get the command again. And then I'm going to specify the task.json that we just wrote. And let's see. Backy, working with JSON, archiving this. Failure to previous errors. Not exactly sure what happened there. Permission denied on line 19. Let's look at this. That's not it. We screwed up something. User bin backy.sh 19. Updated JSON. That's weird. It failed at writing that back. chmod, let's just give 777 so anyone can write or execute this file. Run this sudo again. Still getting permission denied. Dev shm task.json. Not sure exactly where that error is coming from, but it is reading the file. So I think the error is maybe the SHM needs a slash, right? It's just to dev SHM. Maybe it's treating that as a file. So let's try this real quick. I actually had that there. Let's try this. I cannot stat file. Let's see. Is my destination wrong? Let's see if I do. So ... slash, it's from, oh, I have an extra slash here. I put the ... slash in the wrong location. So I think that's it. Oh, no, I didn't. That's right. We have 3 dots, so it removes these 3 and it's left with ... Let's see, directories to archive. It's definitely not archive anything. I just really don't like that line 19 error. I don't know exactly what is going on there. Let's look at the code again. 19. So it's erroring when we try to overwrite this JSON file, and updated JSON's the results of this, and JSON file is the first argument, right? Do we have to be in the allowed paths? Let's see, is allow path. It's setting local path to be the first argument there. And it's doing a directory and directories to archive. So I don't think that's it. Let's just try, let's see. Rename this to t.json, I guess. And let's try running it again. This, I'm guessing, is going to error. There's no way the file name changes anything. Okay. Still nothing. Let's copy t.json. Is it operating out of like backups or something? Let's rerun this. Did this suddenly just fix it? Yeah. I am not sure what's going on there. Maybe dev shm is like a bad directory to run this from. That's my only guess. Let's do var temp. Let's see. Can we copy backups t.json here? What if we run it out of var temp? Permission denied. So it really definitely likes being in my home. I wish I could explain it right now, but I can't. It wants to be in home backups. That is bizarre, but okay. So we ran it. It should have copied to dev shm, and we do have a backup here. So let's do tar xjvf code home, and then we're extracting all the files, and we see root.txt. There is a Python history, but there is SSH, IDRSA, and authorized keys. So let's go in root SSH. There's an authorized keys in IDRSA. So I'm going to chmod 600 on IDRSA. Let's make sure we own that file. We do. So I can just do sh-i, IDRSA, and then root at 127.0.0.1. Log in. And there we go. We have now rooted the box. We could also easily just copy that IDRSA file to our box and then SSH in as root that way, but that is going to be the box. Actually, I lied. After recording the video, there was one thing that was just eating me up, and that is what kept failing on line 19 in the backy script when trying to run it out of the dev shm or var temp directory. And it took me a little while to figure this out with the help of OXDF. We just kept troubleshooting a lot of things, and the answer turned out to be sticky bits. Before we just show the answer, I want to talk about some of the things we did to kind of troubleshoot it, right? If we look at the script, I think it was in user bin. Yeah, this is it. We spent a lot of time just editing around line 19, like putting the current working directory, putting the full path, exactly what it was doing here. Essentially, all that happens is it uses the JQ to remove one ... and then overwrites the JSON file, right? And we just kept being puzzled about, like, is it like changing a directory somehow? Like, why can we not overwrite this file when it's in dev shm? And if you look at like the mount permissions of it, like if we do mount grep shm, it's easy to think maybe this no suid or no dev is doing something. But then that doesn't make sense because it also didn't work in temp or var temp, right? And if we grep on these directories, the var temp directory doesn't have any special permissions. So it still didn't fully make sense, right? And if we run it, we see we get that permission denied. I also let's try chmod 777 on task.json and then run it again, and it still gets permission denied. So why is something getting permission denied when it's world writable, right? That doesn't make sense at all to me. And the next thing we did was run an strace. And to do strace, we had to be the root user first because something with sudo kind of breaks strace, right? So let's go ahead and copy this, and then we're just going to run it as root and see exactly what happens. So we'll do strace and then paste this in. And then we want to look at where the exit is. I'm just going to search up for task.json and see if we see. There it is. We have permission denied. And then looking back, I really don't see anything. Here we go. We're reading the updated JSON, and then it's doing things. And then we just get permission denied. So that didn't really help me. So I went to look at the audit log, which is going to be audit D. And we have Laurel installed on our Linux machines. That makes this really easy, right? So if I grep for task.json out of, audit.log, we can see this. And what I'm going to do is look for when success is equal to no, right? So I'm going to grep that, and then we can also grep success, and then I'm going to replace yes with no. And here we go. We see there is indeed a time when it doesn't succeed, and we're going to go up and see what the syscall is, right? So there's the exit code -13, and it's syscall 257. So I'm going to search syscall table, and then we're going to look at what syscall 257 is. And I think this is fine. The Chromium OS doc, maybe. Let's see. There we go. 257. This is going to be open at. So open at is failing. And that gave us enough to just Google around and go to like ChatGPT and eventually get the answer, but it's sticky bits. So when it's set to 1, don't allow ocreateOpen on regular files that we don't own in world writable sticky directories, unless they are owned by the owner directory. So when sticky bits is set, and that's going to be a 1, so we can do stat dev shm. So if it's world writable and this bit is set, and we don't, the owner of the directory doesn't match the owner of the file, then it's going to be denied no matter what. So if I go to dev shm and we just try writing to this, so we can see it's world writable, echo, please subscribe over top of task.json. Let's just do that. Failed. If we try to append to it, failed. And that's because the dev shm directory is owned by root. It has a sticky bit set, and then task.json is owned by Martin. I don't know exactly why this is the case. My guess is like the temp directory is used for special files. Like you never want things just overwriting your Kerberos tickets and things like that. So maybe it's just like to prevent accidental clobbering of things like that, right? So let's just go ahead and test this out one step further. So I'm just going to go / I'm going to make a directory called sub. Let's make a directory called please subscribe. There we go. So we have that directory. And what I want to do is chown Martin on this directory. And then I'm going to go into the directory. So we'll do / please subscribe. And I'm going to touch IPsec. And we're going to do cd please subscribe. We'll do echo test to IPsec. And that works just as we expected because we didn't set the sticky bit yet on this directory. So let's go ahead and do that. I'm going to do chmod 1755 on dev please subscribe. Not dev, it's just / please subscribe. There we go. And it's still going to work, right? Because the directory owner does match. And we also didn't make it world writable. So if we do 177 like this, it's somehow going to work. If we look at the permission on the file, everything's there. So now watch what happens when we're going to change please subscribe to be root owned. Now, you would think changing the owner to who is going to be writing to this file would not change it being able to write. So I'm going to do that. And now I'm going to attempt to write, and we get permission denied. And it doesn't have to be the root user. We could change it to any user. I want to say like app production also exists on this box. So if I do, let's do chown app production. And now we try to write, it fails. And that's because the directory owner and the file owner don't match, right? And also if it's not world writable. So let's go back to this. Actually, we should do it down here. So chmod 1755 on / please subscribe. So now it is no longer world writable, right? Maybe it is. No, it isn't, right? Let's check. No, we removed the write permission. So let's now go ahead and attempt to write, and we can. So it's one of those weird situations where you don't have the write permission and it works because you root, and then you add the write permission and it no longer works because it's a really specific edge case of where the sticky bit permission comes in to protect against directories. And I can't remember the box off the top of my head, but we also dealt with the protected symlinks once. Because when it's in a sticky bit directory, sometimes symlinks will not be followed because it becomes a protected symlink. But yeah, that is going to be the beyond root of this box, just looking into the sticky bit on directories and why that whole script did not work. So hopefully you enjoyed that. Take care. And sorry for the sloppy cut, but apparently I lied again, and there's one more thing I wanted to include. OXDF had found this after I recorded the video, and I thought it'd be interesting enough to include it because it's a default behavior in bash scripts. And the fact that when they encounter an error, they're not just producing a stack trace and exiting the script, they normally attempt to continue. So let's go ahead and demonstrate that. I'm going to copy a default task.json back over to dev shm, and then we're going to edit this. And we'll put the destination as, what is it, slash dev shm. This is going to be where we want to back up to. And we have to do a comma. There we go. And the directory to archive, we're just going to do home ... root, right? And we didn't try this at first because when we looked at the backup script, we saw the script was removing any ... slashes. So I just assumed it would change this path to be home root, which isn't a path, so it would exit. But it actually removes the ... slash and then attempts to write this file back to the disk. And since that fails, it never actually removes the ... slash, which is, I find, is very interesting. Let's also set verbose to true. So let's demonstrate this real quick. So I'm going to do a sudo user bin backy.sh over top of task.json. And we see it magically works, right? The first thing we have is line 19, the permission denied, but then it goes ahead and archives this. So let's take a look at exactly what backy is, or user bin, the backy script. And here we're just making sure we have an argument. Then the next set, we're making sure that argument is a file. And then we have allowed paths. And what allowed paths is doing is just making sure /var or /home is within the allowed path, right? It's not going to check if ... is in the allowed path and then return 1 if it's not. It just wants to make sure /var and /home exist within directories to archive. So here it's going to run jq on the file we specify, remove ... from it, and then save that to a variable. And then here is where we write that variable back to the file. And at the very bottom of the script, it's going to call the backy binary, which is just a binary that's on GitHub, against that JSON file. So because it's actually erroring here, it never writes it to the disk. And because the allowed path isn't checking for directory traversal, we still hit this and it works, right? There are two ways you could have patched this, right? Or we could have, I should say. After you run the command, you could do like a if statement. So if we do if, I think this would be the last exit code. So we say the exit code is not equal to 0. Then we'll exit and fee. I think that's right. It's been a while since I did bash scripts. I probably should do like a exit 1, I think. So now if we attempt to run this again, we'll have to remove that tarbz2 file. But here, hopefully, it just stops, right? Because the exit is 1. If I do echo like this, there we go. If you did echo test, we have exit as 0. If I try to write something over top of this file, so we'll do please subscribe over task.json. Oh, we have to do this as root because, of course, Martin can write that. So the last command has been 0. Do this. And now the exit is 1. The other thing we could have done to fix this, so let's go back into the backup script. If we remove this if-then statement, you could also, at the top of the script, say set-e. And I forget what E stands for, but this is going to mean anytime the bash runs a program and it comes back with a non-zero, it's going to exit, right? So now let's go ahead and run this. And again, we have that same behavior. So either one of those two things needed to happen in order for that vulnerability to not exist. So maybe that's something, if you're ever running bash scripts, you want to make sure you do, is always put that set-e, because if you don't, a lot of unintended things can happen just because bash is going to continue whenever it comes across an error. And that's not a intuitive thing to think about. So with that being said, This time, I'm going to conclude the video. Hopefully I don't have to make another edit. So take care, everyone, and see you next time.